So children, uh, so we have seen that how single bond is going to exist in the alkane hydrocarbons. Now let us talk about the next category of hydrocarbons, that is the unsaturated. And under unsaturated, what is the first one? The first one is the double bond hydrocarbon, which is called as what? Alkenes. What do we term them as? Alkenes. Okay. Now, how are these alkenes? These alkenes contain a double bond. So again, let us see how these structures will be existing. As I told, it's a double bond between one carbon and the other carbon. So how will I represent these double bond? By drawing two lines. So now what happened? Two electrons of this carbon and two electrons of this carbon have been satisfied. That means still each of this carbon is left with one more two more electrons. So let me represent them also with the line. So this, let us assume this is the first carbon. Okay, if this is the first carbon, that means the remaining two electrons will be bonding with whom? With the hydrogen. Then similarly, if I continue with the second carbon, this is, suppose the hydrocarbon is only of two carbons, then the chain will end up with linking to one more hydrogen atom. Now see, if it is linked to one more hydrogen, how many electrons are satisfied? 3. So that means one more is needed. So now count 1, 2, 3, 4. Okay children, 1, 2, 3. I'm sorry, 1 minute. So you see now children. So let us now continue the second type of hydrocarbon children, that is the unsaturated hydrocarbons. Now under this unsaturated hydrocarbons, we have the first category, that is what are they called as? Alkenes. So what are alkenes? The one which have a double bond. Okay children. So that means a double bond is existing between two carbons. Now as I told in the previous one, alkanes, right now you remember we are talking about only one double bond existing between any of the hydrocarbons. So let me again start with two hydrocarbons. So alkenes, that means how many electrons are shared? 2 electrons. So I represent it with two lines. Now two lines in the sense 2 plus 2, 4 electrons have been shared. That means each of the carbon is still left with two more electrons. So that I will represent with the line. Now if let us consider this, let us consider this hydrogen as the first this carbon as the first carbon and this as the second carbon. Okay, so since it is the first carbon, that means it cannot further go on with the carbons. It will be continued with the other carbons. So the remaining two electrons of this carbon, of the first carbon, will combine with hydrogen. How many hydrogens? 2, because each hydrogen can contribute 1 electron. Then coming to the second carbon. Now the second carbon is also satisfied with only 2 electrons. It is also containing how many more electrons? 2 more. So let us just represent with the line. Now this line you can draw either up or top or below, no problem children. So if this is also going to be bond to hydrogen, then it would be like this. So now you see count children. For this first carbon, 1, 2, 3, 4. Okay children. Similarly for the second carbon, the what are the common bonds for both these? The middle two, these and this. Okay, children. So, and coming to the second carbon, these are the common for both first and second carbon, and the hydrogens of their own respective. So the second carbon will have this, and this also has their bonds. So total how many now? 4. But if in case it does not bond with the hydrogen, okay, rather it would like to continue the chain, then what will happen? Then let us assume that it is linked to another carbon. So then what will happen? Now you see there are 4 electrons being satisfied. That means only one hydrogen the middle carbon is linking to. Similarly, this may also continue like this. Now coming to the third carbon, observe 1 and 2 bonds. That means still it is having how many more to be satisfied? 2 more. So let us draw line. What is this line representing? That one more each electron has been shared. So this again can be with the carbon or can be with the hydrogen. So like this the chain continues, having what? A double bond. Fine, children. Now let us go to the third case. Now what is the third case? Containing a triple bond. And what do we call them as? We call them as alkynes. What do we call them as? Alkynes. Now alkynes will contain water, a triple bond. As usual, let us take water, 2 carbons. So 2 carbons. That means now how many electrons have been shared? 3. So how will I represent them? With 3 lines. That means each of the carbons still is left off with, yes, one more electron to be satisfied, which I am representing again with the line. Okay. Now this again treat this first this first as first carbon and this as a second carbon. So this means since this is the first carbon, it is again going to end up by linking to hydrogen. Now you count how many bonds does this carbon have? 1, 2, 3 and 4. Coming to the second carbon, this carbon also 1, 2, 3, 4. Now this fourth one, yes, as there are 2 possibilities. It may complete by bonding with hydrogen if it is a 2 carbon chain, but if it is not a 2 carbon chain, then what will happen? It is going to link to another carbon. Okay, so thereby what will happen? It will have a single bond with the other carbon. Okay, so now you see now the second carbon has 1, 2,